Hi, my name's Daman Gill,
And I'm Rubal here.
and we're from period 2-1, and we're doing experiment 16D.
So this is sodium carbonate and this is barium chloride, and we mix both of them and there's a precipitate formed. Potassium chloride. No. Okay, and this is barium chloride, and we mix both of them. Chloride, keep it there, and that's sodium nitrate, and we mix both of them and then the precipitate is now formed. This is barium nitrate and this is barium chloride. Where is it? There. And we mix them and they don't make a precipitate. So this is barium nitrate and KCl. That's potassium chloride. And when we mix them, they don't make a precipitate. We added sodium nitrate and barium nitrate and it didn't form a precipitate. Barium chloride and aluminum sulfate, and it made a very dark white precipitate. We added aluminum sulfate with barium nitrate and it made a precipitate. When we mix barium chloride and barium nitrate, it makes a little.
This is strontium nitrate, and that's barium nitrate, and
when we mix them, strontium nitrate and barium chloride together, and potassium chloride and sodium nitrate, and added barium nitrate and
sodium sulfate,
and it made
white.
Barium chloride and sodium sulfate, and it made added sodium sulfate and strontium nitrate, and this one, sodium sulfate and aluminum sulfate. It doesn't make this one precipitate. This is aluminum sulfate and strontium nitrate, and when we add it, we have a precipitate. Sodium carbonate and potassium chloride, and it didn't make a precipitate. Barium nitrate and sodium carbonate, that one, it makes a sodium nitrate and sodium carbonate, and it didn't form a.
In a molecular equation, the reactants and products are neutral compounds. It shows the reactants that reacted to make the product or products, and the products that were produced from the reactants. However, a net ionic equation puts the equation in terms of the ions that are actively involved in the reaction. That's why we see no spectator ions in a net ionic equation. Or in the case of no net ionic equation, it means that all the ions in the reaction were cancelled out. They were all dissolved in the solution. Precipitate is a solid formed when two liquids or aqueous solutions react. When two ions form a compound having low solubility, a precipitate will form due to the mixing of the two ions. Once the solution has dissolved the maximum amount of solute it can dissolve, which is called a saturated solution, the excess solute will pile up to form a solid called a precipitate. When there is a precipitate present, it means that the saturation level of the solution has surpassed its maximum. No precipitate formed because both products, barium chloride and potassium nitrate that formed, are soluble. This means that the solutes will dissolve in the solvent. No precipitate formed because the solution was unsaturated, meaning the solution contains less than the maximum amount of a substance which can dissolve. Therefore, no undissolved solid, which we call a precipitate, is present, and no equilibrium exists. That's why there's no net ionic equation. All the molecules are neutral in the molecular equation. However, in the ionic equation, the molecules are broken down into individual ions. To form the net ionic equation, the exact same ions that are on both the reactants and product side, called the spectator ions, are cancelled. In this case, they all are cancelled out because they all are soluble. They all are dissolved in the solution. This reaction doesn't contain an insoluble compound that would form a precipitate.
Barium nitrate and sodium carbonate reacts to form barium carbonate and sodium nitrate. In this reaction, a precipitate is formed, which is barium carbonate. Barium carbonate is insoluble, which means it won't dissolve in the solvent. This happens because the solution was saturated. The solution has dissolved the maximum amount of substance it is able to dissolve. Once the solution is saturated with the substance, the addition of more of the substance will cause this extra material to accumulate in an undissolved form called a precipitate.
Barium chloride reacts with sodium nitrate to form barium nitrate and sodium chloride. Both products, barium nitrate and sodium chloride, are soluble. That means that the solutes will dissolve in the solvent. In this reaction, no precipitate formed because the solution was unsaturated. The solution hasn't reached the total amount of substance that can be mixed in the solution. Due to this, no precipitate exists and therefore no equilibrium.
Barium chloride and sodium carbonate react to form barium carbonate and sodium chloride. In this reaction, barium carbonate is the precipitate. It is insoluble, that means it won't dissolve in the solvent. This reaction forms a precipitate because it is a saturated solution. The maximum amount of solute has been dissolved in the solution. Adding more substance will cause undissolved matter to be visible, and this undissolved matter is called the precipitate.
Both products, sodium chloride and potassium carbonate, are soluble. The solutes will dissolve in the solvent. The solution is unsaturated, therefore no precipitate formed because the solution hasn't reached its maximum peak in dissolving solute. That's why no precipitate forms and no equilibrium forms.
Sodium nitrate and potassium chloride react to form sodium chloride and potassium nitrate. In this reaction, no precipitate is formed. Both the products, sodium chloride and potassium nitrate, formed are soluble. Thus, the solutes will mix completely in the solvent. The solution was unsaturated. The solution is able to dissolve more solute because it hasn't reached its highest point, when it can't dissolve any more substance. Since it is able to dissolve more substance, no undissolved solute, which is a precipitate, is present and no equilibrium subsisted.
Sodium sulfate precipitate was formed. This tells us that the solution formed between sodium sulfate and barium nitrate is saturated. The solubility of this substance has surpassed its maximum amount of how much substance it can dissolve. Due to this, it is unable to dissolve any more solute, and this leads to the creation of undissolved material called precipitate. A saturated solution is said to form if the dissolved substance is in equilibrium with some of the undissolved substance.
Sodium sulfate and strontium nitrate react to form sodium nitrate and strontium sulfate. When you mix two solutions of different ionic compounds that individually are soluble compounds, they form a new insoluble compound which produces a precipitate. Strontium sulfate is the precipitate formed in this case. The strontium sulfate is insoluble because the solvent has taken the utmost amount of solute in. The solution has reached the point at which the solvent can't dissolve more of that substance, and additional amounts of it will appear as a precipitate. Strontium nitrate and barium chloride react to form strontium chloride and barium nitrate. The products are all soluble, meaning that the solution has not reached its maximum saturation point. If the molecular equation for strontium nitrate and barium nitrate were to be broken down into an ionic equation, all the ions would be cancelled out on each side, showing us that no precipitate was formed. This solution has a higher solubility than compared to a solution that has formed a precipitate because this solution is still capable of dissolving more solute.
Precipitate is formed in the reaction between the two aqueous reactants aluminum sulfate and strontium nitrate because the solution is saturated, meaning that it contains the maximum amount of a substance which can dissolve, so there is undissolved solid present and equilibrium exists. Strontium sulfate, which is the solute, is insoluble. It will not dissolve in the solvent, therefore a precipitate is visible. That's why there is a net ionic equation. Like we mentioned earlier, a molecular equation consists of neutral molecules. In the ionic equation, the compounds are broken down into separate individual ions. The spectator ions are cancelled to form the net ionic equation. This equation involves the ions that are actively involved. And in this reaction, strontium and sulfate are the two actively involved ions that form the precipitate strontium sulfate.
Strontium nitrate and barium chloride react to form strontium chloride and barium nitrate. The products are all soluble, meaning that the solution has not reached its maximum saturation point. If the molecular equation for strontium nitrate and barium nitrate were to be broken down into an ionic equation, all the ions would be cancelled out on each side, showing us that no precipitate was formed. This solution has a higher solubility than compared to a solution that has formed a precipitate, because this solution is still capable of dissolving more solute.
The end!